In this session, let us play with transformer. Okay, why I am saying this is our practical machines are not supposed to be played with. They are not toys to play with, because huge bulk of power it is supposed to transform any machine. Okay, either induction or synchronous or transformer, all machines has to handle bulk of power. So the moment they are handling bulk of power, it cannot be played with. But if you think of transformer, okay, transformer is a static machine, simple machine. So the moment it is simple machine, let us increase the complicatedness by including more into design. Design aspects also already we have seen some part. Okay, and we are going to include playing also. Okay, kind of practical transformer should not be played with. This is not the practical case. Okay, if I think of, for example, here, see, one set of the transformer, this is secondary, this is tertiary, this is primary. Here resistance is connected, here capacitance is connected, and the switch is getting opened by supplying DC. Is it possible practically? No. Okay, so if I think of here, okay, such a kind of connection we are not going to have in practice. Such a kind of connection we are not going to have in practice. Such a kind of connection we are not going to have in practice. But let us play with. Okay, because transformer is a simple machine. So means maybe in synchronous machine, such a playing questions cannot come. Okay, but in transformer it's okay. It's okay because it is simple. Now what are the things we have to recollect such that we can solve these kind of questions? First of all, if I think of this as transformer. Okay, in this transformer, if I supply some voltage V1, okay, so the moment it is positive, it is going to positive, same V1 will come, ideal transformer, or V1 equal to E1. Okay, now the moment this is positive at one instant, at the same instant, whatever may be the terminal which is positive, we are going to keep the dot, meaning that this is positive, so this should be positive, this is E2. Okay, now at no load, how much current it will take? In ideal conditions, forget about it. Okay, so no load current is going to be 0 amperes, or we are going to neglect no load current. Ideal. Now, if I connect one thing here, one impedance here, definitely current has to flow. Current has to flow, meaning that it is absorbing some power, meaning that my transformer is a passive element, so it has to deliver power. Okay, now if it is absorbing some P amount of power or S amount of power, complex power, my source is supposed to deliver the same S amount of power. And if this particular current is leaving this dot, okay, so winding is there, dot is there, after that my current is leaving the dot, so here current has to enter into the dot. Those are the things we have to think, that's it. Okay, and if N1, N2, if you see number of turns, if N2 is more, this is going to be HV, N1 is less, this is going to be LV, that's it. Okay, so means if current is entering into the dot, this current has to leave from the dot. Okay, because it's AC, no? Now let us take this. You can pause the video and you can read that. Okay, now see here, this particular resistance value, how much they have given? 10 ohms. This resistance value is 10 ohms. And capacitance value, and capacitance is charged. Okay, just pause the video and read it. Okay, now capacitance is charged to 5 volts, and plus is on the left pane. Plus is on the left pane, so plus is here, minus is here, which is charged for 5 volts. Okay, now if it is charged for plus on left side and minus on the right side, this minus will come to here, this plus will come to here, this is of 5 volts. And they clearly mentioned that this is 1:1:1 transformer, meaning that if I have 5 volts here, how much will be the voltage here? 5 volts. How much will be the voltage here? 5 volts. But polarities has to be understood. See, here dot is negative, meaning that here dot will be negative. Okay, and that will be positive. Here dot is negative, so it should be dot is negative, it should be positive. Same voltage should be there, so 5 volts after T0 plus. Okay, now see here, they said that this is 5 volts and they are asking how much is this particular voltage and how much is this particular current, that's it. Okay, so if I see this particular current, see, plus is here, minus is here, 5 volts is there, because I know right, voltage across capacitance instantaneously cannot be changed. So T0 minus I got 5 volts, 0 plus also same 5 volts will be there. Okay, and so means once the switch is open, Once the switch is open, how much will be the voltage across this 5 volts only? How much will be the voltage 1:1:1? How much will be the voltage across this 5? Or voltage across this is 5. Okay. Now, if the voltage across this VP, they asked VP in this direction. See here, this is VP, they said, primary voltage. Okay. So, with respect to this, how much is the voltage of this? Meaning that with respect to this, how much is the voltage of this is VP. So, they are asking plus minus VP because shown in this direction. But how much is the voltage we got here? Plus minus opposite side. So, VP is going to be minus 5 volts. Okay. Now, next thing is, if you think of current, say here 5 volts means that here 5 volts. So, from plus 5 by 10. Okay. So, this is going to be 5 and this is going to be 10 ohm. 5 by 10 current is going to be 0.2 ampere. But they ask the current in this direction. In this direction is IR. Okay. So, how much is in this direction current? Minus 0.2 ampere. That's it. Okay. Now, let us think of this question. Just pause the video and read it. And for me, resistance is 10 ohm. Base resistance is 10 ohm. Okay. Now, they said that 90 volts is supplied here. And this is 3:1 transformer. And this is 2:1 transformer. Okay. Now, see here, if it is not connected to anything, under no load conditions, why I am saying this in upcoming problems, you will understand. If you don't have this, under open circuit condition, how much is the voltage here? For example, if I consider plus here, minus here. Okay. So, this plus is here and this plus is here. Okay. When this dot is plus, this dot should be plus. When this dot is plus, this dot should be plus. Okay. Now, these two transformers primaries are connected in parallel or not across 90 volts. See here, 90 volts transformer, 90 volts and 90 volts transformer, 90 volts. So, here you are going to have 90 volts, here you are going to have 90 volts. Okay. So, 90 by 3, because this is 3:1. 3 should be HV side, 1 should be LV side. So, it should be less, meaning that divided by 3 is going to be 30 volts. And here 90, 2:1, meaning that 90 divided by 2 is going to be 45 volts. 45 volts. Okay. Now, if you think of overall voltage by applying KVL here, because these two are connected in series across impedance. Okay. So, see here, from here to here, voltage rise of 45, voltage drop of 30, voltage drop of 30. So, from here to here, it is going to be 15 volts. Then, how much will be the current here? 15 divided by 10 is going to be 1.5 amperes. Okay. Now, what was the question asked? Determine current taken from the source. Okay. Means in shortcut also we can do, because not shortcut, we know that. Okay. Otherwise, in detail also we can do. Let us see. See here, if it is 1.5 amperes, 15 volts. 15 volts. Okay. So, 15 by 10, 1.5. Thank God. 15 volts, 1.5 amperes. So, how much is the power absorbed here? V into I. So, 15 into 1.5. So, 15 into 1.5. 22.5 is the power absorbed. Now, the same power should be absorbed. So, divided by 90 is going to be 0.25 amperes. 0.25 amperes. Okay. For this question, whatever the solution we have given for the workbook, it is wrong because team didn't think that much. Okay. It's okay. Okay. Because first time it happened. Now, anyway, next thing is directly we can do now. Rather than that, like in our workbook solution, if you go ahead, how to solve this? Okay. Let me think of black. See, how much is the current flowing through this? 15 amperes. Oh, sorry, 1.5 ampere. And these two are connected in series. No, these two are connected in series. Current will go like this. Current will go like this. Okay, these two are connected in series. So here, current is entering into dot. See, current is entering into dot. So current has to leave from the dot. And here, current is leaving. See, winding is there, dot is there. Okay. So after the winding, current is leaving from the dot. So current has to enter into the dot. So net current here, if you want to think. Okay. So from this dot, current has to leave here and current has to enter into the node. So this current is going to be difference of that. Okay. This current is going to be this current minus this current. Okay. So see here, simple. This is 1.5 ampere. This is 1.5 ampere magnitude. Directions already we know. And this is 3:1, meaning that this is LV, this is HV. Okay, so 3:1, right side is LV, left side is HV. So LV to HV, if you want to transform current, it should be reduced or increased. Okay, LV to HV voltages are increased, so current has to be reduced. So this current reduction will be 1.5 by 3 is going to be 0.5 amperes. And see here, this magnitude of current 2:1. So if this current is 1.5 ampere, this current should be 0.75 amperes. Okay, so 0.75 minus 0.5 is going to be 0.25 only, because power absorbed by this and power delivered by this should be same. Directly we can do that way rather than kind of lengthy way. Okay, now let us think of this question. Figure below shows, means you can pause this and you can read this. Okay, now here this is 100 volts 50 H, and here this is 10 ohm is given. Determine current drawn from the source. This also can be done like powers are equal and all. Okay, first of all, see here, this 100 volts when load is not connected. Okay, let me go ahead with when load is not connected first. After that, let us think of when load is connected or external connections are connected. Okay, see here, when 100 volts is supplied from here to this is 3:1 transformer and this is 2:1 transformer. Okay, so on primary side, if I think of 3 turns are there, here how many number of turns will be there? 1 turn. Here if I think of 2 turns are there, here 1 turn. So on primary side altogether how many turns are there? 3, 2, 5 turns. Okay, if I think of primary side 5 turns are there for combined series connection, how much will be the EMF per turn? Is going to be 20 volts. 20 into 3 turns. 20 into 3 turns is going to be 60 volts here. 20 into 2 turns is going to be 40 volts here, such that this 100 will be distributed as 60 and 40. And wherever dots are there, plus, when this is plus, this is going to be plus. And this is plus. When this dot is plus, this dot is going to be plus. That's it. Okay. Now, when load means external connections are not there, I am assuming. Why I am saying this, you will come to know in the next question. Okay, now if I think of 40 volts are getting injected here, 2:1, in the sense this should be LV, meaning that voltage should be reduced. 40 by 2 is going to be 20 volts. Okay, this would be better. Now after that, 60, 3:1, it also will be 20 volts. Okay, now if you see, plus and plus are connected to here, minus, actually this is a crossover. Okay, now minus are connected, plus are connected. So can I say these two are connected in parallel? Yes. Okay, so if I think of plus minus, if I think of course DC, it is not DC, I know. Okay, just for reference, that's it. Plus minus, so plus are connected, minus are connected, so this is connected with resistance of 10 ohm. Okay, see, plus is connected, minus is connected, plus is connected, minus is connected. So net voltage is going to be, see, plus, this is plus, minus is going to be 20 volts. If this is 20 volts, how much current it would take? Directly 20 divided by 1, 2 amperes. So how much is the power absorbed here? Is going to be 40 watt. Same power has to be absorbed here, no? It has to be delivered here, no? So 100 volt source, in order to deliver 40 watt of power, how much should be the current? 0.4 amperes. Deal done. But some guys may go with a bit lengthy method, okay, like our solutions. Okay, let us think of that way, because with that you will get confidence. Okay, now see here, this is 2 amperes. Now I cannot say this will give you, this is 2 amperes is fine, but I cannot say this should give 1 ampere, this should give 1 ampere, because the primaries voltages are different. Okay, now let us think of this particular current as Ix. Okay, because means everywhere from plus only current should come out. So plus only current should come out, this is Ix, and here plus only current should come out, this is Iy. Now what is Ix plus Iy equal to 2? Okay, now see here, Ix plus Iy equal to 2. Now what is Ix? See, because these two are connected in series. So the moment these two are connected in series, meaning that current should be same. Current should be same. Okay. Now if I think of this current as I1, okay, so if this current is I1, how much will be this current? This is HV, this is LV. Okay, so if it is I1, Ix should be 3I1, because this is HV, this is LV. So HV side to LV side, voltages will reduce, currents will increase by the same ratio. So I1 equal to 3Ix, and again here also same current will flow. So same I1 with respect to this, if this is Iy, so this should be I1 equal to 2Iy. Getting my point, right? Now Ix plus Iy, just a minute here. Ix is here, I1 is here, this is HV, so voltage should be less, so 3 times Ix, it's fine. Okay, now if you think of Ix, how much is Ix? I1 by 3. Okay, just a minute. This is HV side, current should be less, it should be more, so Iy is going to be 3I1. Yes, I have done a mistake. It's fine, simple. Okay, see here, this is LV, this is HV. LV side current should be more, HV side current should be less. Here also I1 current, here also I1 current. Okay, so this side current should be less, this side current should be more. So Iy equal to 2 times I1, and Ix equal to 3 times I1. Okay, because here current should be less, here current should be more. Okay, now see here, Ix plus Iy equal to 2. How much is Ix? 3I1 plus 2I1 equal to 2, or I1 equal to same 0.4. Same will come, because conservation of power. Okay, if load is demanding some power, compulsorily source has to deliver the same amount of power, because transformer is a passive. Now let us think of this question. Beautiful question, and it may lead to quite confusions also. Okay, so as it is a bit good question, let me try it again. You can pause the video and you can read it if you want. Let me increase this. Pause the video, read it. Now I'm reducing. Now see here, this is primary, secondary of first transformer, primary and secondary of second transformer, and this is 3:1 and this is 2:1, and here this is dot, and here this is dot. Same diagram I'm trying to draw, and these two are connected. This is connected to 100 volts, 50 H. Okay, and now these two are connected like this. And when it is under node, this is beautiful question, very beautiful question. Now means nothing is connected here. Let us see first. When nothing is connected here, let us see first. See here, see again 3:1, 2:1. Okay, so total number of turns are going to be 5. So here we are going to get dot plus minus 60 volts plus minus 40 volts. Okay, such that 60 plus 40 equal to 100. Now when this is 60 volts, first of all dot positive, dot positive. Okay, this is 3:1. Voltage has to be reduced by 3. So 60 divided by 3, 20 volts. Okay, and 40, 2:1. 40 divided by 2 is going to be 20 volts. Without having any connection. Now if I see, if I connect one voltmeter here, just like that. If I connect one voltmeter here, of course in the question they didn't ask that, but if I connect one voltmeter here, how much voltmeter reading will be there? See here, plus to minus, minus to plus. Voltage rise equal to voltage drop. You are going to get 0 volts. Okay. Now, forget about it. Maybe, okay, forget about it, not required. Now, let us think of the way they ask the questions. Okay. First thing here is, voltmeter is connected here. Okay, so if voltmeter is connected here, how much voltage it will be? For example, nothing is connected here, my voltmeter reading is going to be 20. Okay, if for example, if I short circuit this, what will happen? Nothing will happen, because minus 20 equal to plus 20, net voltage is going to be 0 only. So under that condition, even if I short circuit this, how much is the voltage? 20 volts only. Okay, anyway, that was the last question they asked. Yes, better. Now, what did they ask? maybe let me think of increasing this. Okay, so voltmeter is here, this is short, this is not crossover. See here, this is short. Okay, this is not crossover. When the switch is closed here, how much is the voltmeter reading? Okay, now in this case, see here switch is there, and here this is voltmeter is there. This is S1. Now means without having any external connection, situation is going to be same. Now for example, if I close this, meaning that my secondary is shorted. Okay, so the moment secondary is shorted, secondary induced voltage is 0. So primary induced voltage, this will become to 0 volts, meaning that here this will become to 0 volts. I told we are trying to play with the transformer. Okay, now kind of magnetically coupled network, let us consider. Okay, so when this is 0, here can you change the source voltage? No. When this is 0, kind of short circuit, same 100 volts will appear here now. If 100 volts is appeared here, 2:1, how much will be this voltage? This voltage is going to be 50 volts. Okay, when the switch S1 is closed here, under that condition, my voltmeter reading is going to be 50 volts, deal done. Now let us erase this. Okay, so this is the case without having any external connections. Now let us think of this only for you. Okay, when S2 is closed, they connected external some resistance across the secondary, and they are connecting voltmeter here. Okay, meaning that in this case, when S2 is closed, they connected one resistance here, and they are going to connect voltmeter here. How much it would be? Okay, forget about resistance values and all, it is not required. Now see here, the moment 20 volts across 20 volts, of course, under immediately, like at that instant whenever I close this particular resistance, immediately 20 volts is there. So the moment 20 volts is connected across resistance, keep focus, 20 volts is connected across resistance, some current will flow. Now in order to come, means the moment currents are leaving from the rod, currents has to enter into the rod. That's fine. Now if currents are leaving here, if currents are entering here, in order to compensate the MMF, some kind of fluxes and all, so the same current is supposed to flow through this, because primaries are connected in series. Okay, now if the same current is supposed to flow through this, what about this particular load, this particular transformer? Secondary load is not there. When load is not there, current should not flow. Okay, if current load is there, under that conditions, reflected currents will be there, such that MMF compensation will happen. The moment load, only voltmeter. So the moment load is not there, it is not supposed to take current, but it is taking current in order to compensate here. Then what will happen? Because without the load, okay, without the compensation of secondary MMF, if some currents are flowing, voltage will increase. Okay, now means the moment voltage start increasing here. Okay, the moment voltage start increasing here because of this particular current, then this particular voltage is going to reduce, this particular voltage is going to reduce, this particular current is going to reduce. Okay, it will not be continuous process. At one stable point it will stop. Okay, meaning that means out of 100 volts, previously 60-40, now from 60 it is going to be reduced and 40 it is going to be increased. The moment it is increased, 2:1, this also will be increased, meaning that my voltmeter reading will be more than 20 volts, up to that only we can say. Okay, now let us think of one more condition. Better. Okay, now if I think of one more condition, see, when S3 is closed, it is going to be short. That point already we discussed, right? So when it is closed, this particular, okay, when S3 is closed, at starting only we discussed, right? When this is closed, means plus minus 20, net is going to be, nothing is going to happen. When you connect voltmeter here, it is going to read 20 volts. Okay, such beautiful problems, very all the best.